Today, I'd like to introduce you to the concept of algorithms as it's so central to computer science and especially artificial intelligence. If you read or hear about AI, the term algorithm often is not far away. Sometimes it's even used interchangeably. And my impression is that's often used rather with a negative connotation. Algorithms do something we do not want, we do not understand or cannot control. So let me explain to you what an algorithm is, and later when we talk about machine learning, we come back to this negative connotation. But before I'm off to Apagayo Island, please consider subscribing to my channel and hitting this little bell, then you will not miss my next adventure. So, what is an algorithm? Let's have a look on the definition. An algorithm is an unambiguous set of instructions for solving a problem. That means you have a certain problem, you follow the instructions of the algorithm, and then your problem is solved. Still pretty abstract, as we have no idea yet what kind of problems we are talking about. But we can already exclude all the problems that require personal judgment or taste, because this wouldn't be unambiguous. An algorithm consists of a finite number of well-defined steps. For the most part, this simply rules out anything that would run forever from being an algorithm. But for AI, this point is of central relevance because it's an open question whether what runs in our brain can be described by a finite number of steps. Or in other words, can our brain function be described by algorithms and thus be simulated on a computer? Most people assume that an algorithm is only something that runs on a computer, but this is not correct. For sure, everything that runs on a computer has to be an algorithm, but the concept of algorithms existed long before we had computers. And therefore it's possible to write down an algorithm as plain text. I will give you some examples of algorithms in a minute, because it gives you a first impression what can be automated using a computer. The final part is that as a result, a particular input will be transformed into a particular output. But let's take a look at some concrete examples. Imagine you want to open a restaurant. You have a nice location, but the first thing you need is a license or permission to operate your restaurant. So you go to your local authorities to apply for a license. And typically, you have to fulfill certain requirements. Your restaurant has to have some size and capacity, restrooms, a fire exit, and you have to obey the required hygiene standards. There might be many more things you need to fulfill, but assume you have everything you need to apply for a license. What now follows is an algorithm. You hand over all the information to your local authorities, that's the input. Then they follow a process given by the instructions of the local provisions to check the correctness and completeness of your information, and as an output you either get your license or rejection. This is typical for many public provisions in constitutional states. They are basically algorithms because you don't want the outcome to depend on who your corresponding official is. Whether you get a permit or how many taxes you pay should not depend on the fact whether the official likes you or not, or how much bribe you pay. And that's the reason why there's a huge potential of automating processes in the public sector, because many of the processes are algorithms by intention. For sure there are certain exceptions I will come to in a minute. Now you have your permit and you go for shopping the ingredients you need for cooking delicious dishes. A typical algorithm is calculating the sales tax you have to pay. There are different rules depending on your country or state and what kind of products you purchase, but there are always clear rules on how to calculate the tax, whether manually or with a computer. And finally, you are ready to open. Just you have to cook some dishes to serve to your guest. And guess what? Most recipes can also be considered algorithms as long as there are no secret ingredients. That recipes are indeed algorithms can be best understood by looking at fast food franchise. The burgers taste the same wherever you buy them and whoever has cooked them. The process has been standardized and does not depend on individual humans. And that's the reason why cooking can be automated through robots, what several companies are working on. There are two things left I would like to tell you about algorithms. What I have given you as a definition is only a pretty rough one. There is a whole scientific subject on computability, working on what theoretically can be run on a computer. It's all about things like Turing machines, but also what different algorithms can be run on quantum computers. This is far beyond what you currently need, and I will leave it aside. The other thing is about processes you cannot automate with a computer because they cannot be written as an algorithm. Anything requiring human judgment is not an algorithm, be it the judging of dishes in a cooking contest or sentencing somebody in a trial. I know there are countries that use computer systems in trials. The idea is to make the decisions more objective. Unfortunately, the opposite is closer to reality. I will come back to this point at some time, but for now I will leave it aside. Also, all creative tasks are out of scope for algorithms. For sure you can use algorithms or computers to generate something new. But for me, creativity means creating something new with meaning. And so far, nobody has been able to encode this meaning into an algorithm. The last example concerns anything requiring empathy. What you can infer from this situation is that the boy is longing for the lollipops on the cupboard. No algorithm has been found that could do anything the like. So for the most part, there's nothing mystical about algorithms. It's just a set of instructions where you exactly know what the algorithm is doing. This will change a little when we come to machine learning algorithms.